Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Chaos Construction Y Sums by KNT. And here are the rules. We have normal chaos construction rule set, which is place the numbers from 1 through 9 exactly once in every row, column, and region, and each region is orthogonally connected and must be located by the solver. So what is an orthogonally connected region? It would be something like this, where you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from here to here, you just go through these edges here, and it would stay within the region all the way through. What is an example of an invalid orthogonally connected region? It would be something like this. These two cells can get to each other by going through edges while staying within the region, but they can't get to the other cells in the region by going through edges while staying within the region. They have to go through a corner, or they would have to go through an edge but exit the region, and that is not allowed in orthogonally connected regions. And that's how chaos construction works, or orthogonally connected regions in chaos construction. Okay, we have a number outside the grid indicates that the first y numbers looking into the grid sum to that number, where y is the xth number from the direction of the clue, and x is the first number from the direction of the clue. A question mark may be any positive number, so it's not 0. It has to be above 0 then. So what does that mean? So, okay, we have x and y in a column. X is the first number in the direction from the clue. So therefore, this would be x here. Y is the xth number from the direction of the clue. So if this were 6 here, that means the y here would have to be here. And so y is the xth number in the direction of the clue, and y and x is the first number, right? So x is the first number. That tells us where the y number is, or where y is, I should say. And that's the x number in this direction. So this is, again, if this were 6, then this would have to be y. So then you could have y be 2 here. Oops. And this would be valid because a number outside the grid indicates the first y numbers looking into the grid sum to that number. And if this were 6 and 3, then this would be valid because x would be 6. It's the first number from the clue in that direction. Therefore, that's saying that y is the x digit, which would be 2. And then that would force this to be 6 and 3 to add up to 9 because the sum of the first 2 digits, which is the y number, is equal to the clue outside the grid. Interesting. So I hope that was clear. It's basically one step removed from x sums. X sums is usually basically this x tells you how many digits that this number sums up is the sum of, right? The number of cells, I should say, that this number sums up to. Or this sum. Okay. X sums is normally the x is the first digit, which is always the same. And that's telling you how many cells you count to sum up to the number that's outside the grid. That is the clue. So normally in x sums, this would say the first 6 digits must add up to the clue outside of the grid. But we have one step removed from that, which is we have an x here, which is 6, And then that tells us where the position of y is, and then y tells us the number of cells seen from this clue, which must add up to the clue. Hope that made sense. Okay, those first y numbers comprising the sum of the outside clue are all part of the same region. And if y is less than 9, the y plus 1 cell is in a different region. So this would actually be satisfied if we had pink and pink be part of this region and then green go here. Because these two cells are part of the same region, and the y plus 1th cell is in a different region. So that would satisfy that. Furthermore, of the up to 9 cells surrounding and including the cell containing y, exactly y belong to the region containing the cell containing y. Oh, that's a thought twister. But anyways, so in y, so the 2 here is y in column 6 for this cell here. Only 2 of the cells in the 9 surrounding cells, so in the 3x3 box surrounding this y cell, belong to the same region as the cell containing y. So you could have yellow, yellow here, and then the rest be other regions. So something like red and blue here. And this would be valid. You could not have 3 yellows, though, in this region, because this is 2 specifically, right? So the 2 signifies that in the surrounding 3x3 box, only 2 cells are part of the same region as the y cell. And it says one number is already given. That can't be a y, though. So I mean, I guess. This is just saying that one number is already given. Well, it's not going to be part of a y sum because you can't have 2 digits adding up to 21, and there's no other clue outside that points to it. So I'm not really sure why we need that information, but sure, okay. We've got one number is already given. That's it. Anyways, those are all the... I'm not really sure. Yeah, this seems like a very extraneous rule for this part. I don't know why we have to have one number is already given. Because it's not a y sum. It can't be. Because the first y digits, which would be 2, if this were a y, the first 2 digits are never adding up to 21. So, anyways, we do have one number that is given. Those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this can never be the y because of that. Y can never be 1, though. If we ever have y as 1, it's saying that only one of the surrounding up to 3x3 squares are in the same region. And obviously that's not going to work. Because every region has to be orthogonally connected, which means you're guaranteed at least 2 cells are going to be part of the same region. So y always has to be at least 2. um, since y is always at least 2, anytime you have a y sum clue, it's always going to be at least 2 in length, right? Because the first y numbers are part of the same region. So these must be part of the same region. These must be part of the same region, as must these two, as must these two, and these two. Same with these two. So these two are part of the same region. These two are definitely part of the same region. So must these two. These two. 18, you cannot have 2 digits add up to, so it must be at least 3 here. 27, it has to be at least 4. 8 must be at least 2. 21 has to be at least 3. And with only a 2, 2, 8, and 9 only add up to 19, so this actually has to be 4. Oh, that's interesting. Huh. These have to be different regions then. Well, it obviously have to be different regions anyways. If this were the same region, I guess that's possible. You could add up to 27 and 21, but the problem is that this would be a set of 16 cells here, which doesn't divide up evenly into regions, right? It's 16 cells. You either have a 9 region and a 7 region, obviously, which doesn't work, or an 8 and an 8 region, which obviously doesn't work. You have to have two nine sets of regions. So this is guaranteed to be 4 of the same region. This is guaranteed to be 4 of the same region at least. And they cannot be part of the same region because that would block this into regions that don't work. Okay. That is interesting. Hmm. Um. Hmm. The x in this part of these y sums can never be 1, except for the question marks. Oh, so this is not guaranteed to. You could have 1, 1, 1. No, because 1 doesn't. Yeah. 1 doesn't work. One doesn't work as a y, right? So if you have 1 be the x sum, if you have 1 be the x, that's also saying that y is 1 also, which means obviously that doesn't work. So yeah, these are still guaranteed. So you cannot have 1 here. You can't have 1 here. That's actually very interesting. So we have 2 through 8 here. This must also be 2 through 8. We also know that these two are the same region. But we don't, the thing is, we don't know which of these regions are the same as each other. There could be certainly some that are. This is 2 through 7 here. Hmm. So that's interesting. The y in column 6 for both sides is either 2 or 3. Because you can't have more than 3 digits add up to 9 or less. So the same is for row 6 in this direction. The y has to be 2 or 3. Oh, the y in this 8 cannot be 3. Wait, can it be 2? It can be 2. It can be 2. Okay, so the y in this direction cannot be 3. And the reason why is, where can the y... If this is 3... Oh, wait, no, it could be 2, 5, and 1. Never mind, it could be 3. Shoot. Okay. Right, for the 8. If y is 3, that would mean it cannot be 1, 3, and 4. And the reason why is this can't be 1. If we had tried to have it 3, that would say that the y is in the 3rd position, but the y has to also be 3, which is obviously a contradiction. So if we try to have 4 here, that would say that y is in the 4th position, but then to add up to 1, 3, 4, to add up to 3, to add up to 8 doesn't work because 3 is outside of the first 3 digits. So you cannot have, if y is 3, the sum adding up must be 2, 5, and 1. And it can obviously 2 can't be here because if you have 2 here, that would force y to be in the 3rd position. And then 2, 3, and another digit never add up to 8. Sorry, another unique digit never add up to 8. And if we have 5, so the only way this can be, so this is either 5, so if y is 3, that means this is 3 here. 5, we have 5 pointing to 3, which says the first 3 digits add up to 8, so this would be 1 or 2, this would be 1 or 2. Oh, that's interesting how that interacts with that. The remaining digits here would have to be what? 4 through 4, 6, 7, 8, 9. Obviously the first 2 digits cannot add up to 8. Sorry, 18. First 4 digits can no longer add up to 18 because the minimum's 4, 6, 7, 8. So it'd have to be 3 digits adding up to 8, but we don't have a 5 available to point to this 3. So we know why. So we know that y for the 8 clue in row 6 cannot be 3. It has to be 2 then. Because the only way it could be 3 is if in this scenario. This is 1, 2, 5, but then that breaks the 18 clue for a y sum. So it cannot be 3, therefore it must be 2. And 2 can't be here, because that would say y is in the 2nd position. So that doesn't work. So this is guaranteed to be 2, which means we have a definite border there. So this is another region here. And if we try to have 2 be here, that doesn't work. So this cannot be a 2, 6 pair. So what can we have? We could have 3, and the y is definitely 2 here, which is interesting. So we could have 3, 5, no 4s, no 6, 2, or 7, 1. Interesting. Can it actually be 7, 1? That's interesting. So if it's 7, 1 there, that would say that y is in the 2nd position. You're guaranteed these are the same region, so this has to be completely different region. So you'd have to go that way. And that doesn't work. 2, to add up to 18 with 2, it has to be 7 and 9, but we already have a 7 in the row. Therefore, this has to be 3 or 5. This is 3, 5 as a pair. And then 2 has to be either here or here. It cannot be here. So therefore 2 has to be here. Which means this is x is 3, this is 5, So we have at least 3 digits adding up to 18. That could work with 9 being there and then 3. The rest of this row is 1, 4, 6, 7, 8, and 9. Can we have 4 digits adding up to 18 is the question. Obviously, this can't be 1 here. 4 digits adding up to 18. Minimum, so you could have, yes, 1, 4, 6, 7. 1, 4, 6, 7. But the problem is then you can't have this pointing. 4 cannot be both in the section and the y, right? Because it would have to be 4 pointing to 4, but then that would say 4, the y has to be whatever the digit that is pointing to 4. Did that make? I hope that made sense. If you have 4 as a sum, as a y sum, it has to be 1, 4, 6, 7. So if y is 4 for this y sum, it's 1, 4, 6, 7. But how do you point to that 4? Obviously, it cannot be the first digit, because then that would say that y has to be in the 4th position, but we want it to the y to equal to 4, so that doesn't work. And then 2 and 3 are not available to be pointed at, so therefore that doesn't work. So it has to be 3 digits here, adding up to 18, which means this must be pointing to the y at 3. So this only has 3 digits that are the same region as it, because this is y. So what are these? To add up to 18, we have 1 and 8, no 2, 7, no 3, 6, or 4, 5. So this is done here. So this only has 2 cells that are part of its region, so it cannot be part of orange here. This is not 1, 8, or 9 here. Interesting. Only 2 of these cells are part of its region. So it either goes 2 here or 2 here. Only 3 of these cells are part of its region. So let's mark the y's with a green circle. So this is a y, 3 is pointing to 2, 9, this is a y, 9 is pointing to 3. So it's either 2 this way, and then it's done. I guess you could technically have this be a region. No, because these can't be part of the same region. So this is definitely border here. So you cannot go 2 this way. If it's 2 this way, it has to go out this way. So it must connect to here. It can't be part of the dark region, and then the dark region's blocked. So this must go this way here. Because if we try to go here, dark is not part of that region. You have to... This only has... Well, maybe that could work, actually. Hold up. So if we have pink go this way... Oh, no, it doesn't work. Pink is not part of dark. Dark has to get out. It's only 3 cells that are part of its region here. And this can't be pink here. So this can only be dark then left. But then this has to be a different region, which is not going to work because pink blocks here. This other region blocks here, and dark is not a full region. So that's why this can't be pink, which means all of these are the same region. So we have boundary this way. That's interesting. Only one of these is part of the same region. So it could be that this goes out like that. Or just goes out that way. This cannot be part of pink. So the y here has to be either 4 or 5. We don't know, though, what it is. This cannot be obviously more than 3, so that's also possible. Huh. So this can never be 3. Oh, that's some funky ways that works. Huh. So what are the sums here? You could have 8 and 1, 7, 2, 3, 6, 4, 5, or 1, 2, 6, 1, 3, 5, 2, 3, 4. Same with this side. Um, hmm. Hmm. Um, this could be part of the same region as that. That is technically possible. Okay, say this was part of the same region. So these would all be part of the same region. This would necessarily have to be part of that region. So what happens in that scenario? These would add up to 12. We'd have 1 here. This is 8. The y here would obviously be 4. But none of these. So if we had 4 here, it would have to be 1, 2, 4, 5, adding up to 12. But if 4 were here, here, or it can't be here, obviously, that would be pointing to the 1 as the y. So it would have to be, if this 4 is one of these, it would have to be 4 here and 2 pointing to that. But this doesn't have 4 cells that are in the same region in the neighborhood. It's 6. So that does not work. So 4 would have to be outside of here. Therefore, this would be 2, 3, 6, or 8. Sorry, 1, 2, 3, or 6. And this would then have to be 6 here because the 4 is not part of these cells, so it can't be 2 or 3. So 6 would be here. This would be 4. And this would have to be 4, 5, and 7 as a triplet. So that could work. This has 4 cells that are part of its region in the surrounding 3x3 box. So that could work. Okay, so that's not a good place to go down right now. Maybe the 9s. The 9s seem like the most potentially restrictive. 27, the y has to be either 4, 5, or 6. Hmm. Right. Hmm. Um, hmm. So if this is dark, I guess technically this could be yellow here, right? You could, no. Well, you could have all of this be blue. It's kind of possible, I guess. Hmm. We do know, okay, so there's a boundary here. That's definitely certain because only one out of these 3 is part of the same region. Sorry. 3 out of these 3 is part of the same region, and we have 2 of them here. So only one of these can be. So that means the other one has to be a different region. So therefore, there's always a boundary there. Hmm. Can this be 3 here? Um. Oh, the y here in column 9 has to be 5 or less. 5 to 2. Okay. They both can't be pointing at 3. Right? If they were both trying to point to 3, you would have 3 digits here adding up to 9 and 3 digits here adding up to 9, and that's not going to work. So one of them is guaranteed to be 2. Interesting. Huh. Right, because you can't have 2 3s adding up to 9 on each side, right? That's a minimum of 6 digits trying to add up to 18, which is not possible. So 6 digits adding up would add up to a minimum of 21, obviously, which doesn't, so that doesn't work. So one of them's pointing at a 2. That's very interesting. That means that the y is only 2. And it's saying of the surrounding 3x3 box, only 2 are part of the same region. And it cannot be here. It cannot be here. It can't be here because if this is 2 here, these have to be at least 5 digits adding up to 27, right? 27 minus 2 would be 25, which 3 digits are never going to add up to. So if this were 2, it'd have to extend to 5 here. And then this would have 3 cells, part of its same region. So 2 can't be here, 2 can't be here. 2 cannot be any of these. 2 can't be here, 2 can't be in these rows because of 2's in the rows. And 2 can't be here. Because if 2 were here, in one of these, it would be 2, 7 as a pair, but it has to extend out somewhere else here, right? And 2 being... And you cannot point to 2 here as a 9 because the 9 cannot be in either of these spots. Oh, so that's an interesting aspect. So that means this can't be 2 either. Because we are guaranteed a 2 is somewhere in this row as a y. Column as a y. And this can't be 9, and this can't be 9, which means 2 can't be in either of those spots for the x, right? This one cannot have 2 here, so therefore it can't be 2. Can't be 3 here. No 5, no 6, and then it could be 7, but not 8. Because if this is 8, this would be 2, but these would have to be the same region, and you have to extend out somewhere to get connect to that region. So this is 4 or 7. This could be 3. Cannot be 4. Can't be 5. Can't be 7. Again, cannot be 8. Because if we have 8 here, That means these two cells are part of its only region, and then it can only be 2 that's part of it. So this can't be 8. So this is 3 or 6. This is 4 or 7. This can't be 7. If this is 7, that would be 2. And then that would... So this has to be 4 here. For 3 digits to add up to 9, it would be 432. But then it would have to be pointing to 3, which is not possible. So this 4 must be pointing to 2 here. This is 4 and 5. This is a Y. I guess maybe we could use black circles. Or maybe we could just draw the... whatever. Let's use blacks. Let's use black circles. So that's a Y. And this is a boundary here. This must be 2, but it cannot be just 2 this way. It cannot connect to here. It cannot... If it goes 2 this way, it has to go out this way, because it can't be here because that's too many cells which are part of its region. It can't be part of this because too many cells are part of that region. Therefore, this must go this way. And I think it has to... It cannot be part of this orange, can't be part of this medium. It has to be part of, like, this black. 1, 2, 3, 4, 5, 6, 7, 8. It could go this way. We don't know. So this is definitely boundary here. This is 4 and 5. That eliminates 4 here. And can this be 3 digits adding up to 9 now? The answer is no. Can't be 1, 2, 6 because of 2 in the column. Can't be 1, 3, 5 or 1, 4, 5 or 2, 3, 4. So this has to be 2 digits adding up to 9 here. So this is 6 and 3, which means because this points to the 2 here. Therefore, this is boundary there. This can't be 6, it's 7. That eliminates 7 in the rest of the row. We have 1, 8, and 9 remaining in column 6. That's how that works. That was interesting. Can this light be part of this medium region? And I think the answer is no. If it is, that means this is a separate region. Then you'd have 2 separate regions here. So this is definitely boundary. And you'd have 2, well, shoot. That's not gonna... Oh, this could be part of this region. In fact, I think it has to. Right? Because if this is not part of this region, say these are 2 separate regions. So we try to have this be part of a region. This is a separate region here. This has to connect to... This can't be part of orange. So this is one region. This is a separate region. That's 2 separate regions in not very much space. 14 cells. And that's not possible. So that's why these have to be separate regions. If we try to have this as a separate region than this, that's not going to work either. So we definitely know these are separate regions. If this is the separate region than this, where is this going to be? It can have 9 here, but then this can't go out this way because this is only 2 cells. So this must go out and connect to this region. So that's too big. Oh, I guess it could do this. I could go here. So this cannot be, this has to be the same region as this. So this is orange. We have to go dark, dark here. This has to be medium because this is not going to be a full region here. So this is dark. We have 1, 2, 3, 4, 5, 6, 7, 8. How does that work? Okay, so this is medium also. You could have medium go that way. 1, 2, 3, 4, 5, 6, 7. So 2 out of the 3 here are medium. So it could be it can't be medium, medium. So this is definitely, sorry, dark, not medium. This is dark, dark. So one of these is dark. So either this is dark or medium, and this is dark or orange. One of these, though, needs to be a 5 somewhere here as a Y. Well, that can't be 5. That can't be 5. None of these can be 5. This can't be 5 because if it's 5, it has to be dark here. I don't think... Oh, this is the only place to be 5. This can't be 5 because that's 4 cells surrounding it. So therefore, this must be a 5 here, which makes that 8. So this cannot be 8 here. And this must have 5 cells that are in the same region, so it must be that way, which means this has to go this way because it cannot be part of blue. I don't know. Do we make this yellow? This must be part of this region because there's no other place for blue. So this is blue here. So this must connect. This can't be some other region, so this is blue here. So this is a Y. We have 8 here. To add up to 27, can we have... So this is 8 pointing to the 5. This is another region. Yellow has to get out. So this is yellow. Okay. Boundary. And this is yellow or blue. Okay. Boundary here. This is 4. Can you still have 4 adding up to 27 without an 8? Yeah, I think so. 6, 7, 9, and 5 is possible. 5 okay, so 5 and 3 have to be, well, not necessarily. We could go orange there. That's right. 5 is definitely have to be part of this part of orange to add up to 27. So that means either 4 digits or 3 digits add up to... Oh, that's going to be interesting, though. It can't be... Okay, so 5 is definitely going to be part of this region here, adding up to 27. Because it can't be here, can't be here, because of 5's in the column. So it has to be part of this region here, adding up to 27. But if we point to it as the Y, it's not going to have 5 cells that are part of the same region as it here, if it's either here or here. It can't be either of these, and even then, that doesn't have 5 digits that are part of the same region. So that means this must be 4 here. So this is 4 here. This has to be a 5 because of 5 in the can't be here or here. This is 9, and this must be a 6, 7 pair to add up to 27. Therefore, this cannot be dark. It's orange here, which means dark has to go that way. That's actually pretty cool. Anyways, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 as a region. This is a separate region. We don't know what. This has to be 3 because there's no other place for 3 in the orange region. That leaves this as what? 1, 2, and 4? And we have 6, 7, 9 remaining in the blue region, and this can't be 6 because of the 6 in the region, so it's 7, 9 as a pair, which eliminates 7 here, so this is 6, which makes this 7. Remaining digits of the dark region. 2 can't be here because of 2 in the row. This can't be 2, so this must be 2 here. This must be pointing at a 4 or 5. We're not sure which. These digits have to be 1, 2, 4, or 8. This can't be 2 because of 2 in the column. Remaining digits of the dark region are 1, 3, 6, 7, 8, 9. Obviously, no 3 or 8 here, no 3 here. So 3 is one of these two. 7 is eliminated from here by 7 in the column. Okay, this can't be 9, this can't be 9 because of 9 in the column. $21. So this is either pointing at 4 or it's pointing at 5 for the x. Remaining digits of yellow cannot be 5 or 3. 1, 2, 4, 6, 7, 8, 9. And obviously no 2 here because of 2 in the column. No 7 here because of 7 in the column. No 2 here because of 2 in the column. Where's the 2? Well, 2 in the blue region could go out here. Huh. Okay. So this y is set. This y is set. This has to be 4. Remaining digits of row 5 are 1, 2, 3, 4, and 8. Obviously no 2. Oh, this is pointing at 6. So therefore, this is 4. That means there's no 4 here. There's no 4 there. This is a y. Interesting. So this is done. 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 This is not done. So we have this one, and this one for the y's. How do you add up to 21 with 4 digits? I guarantee 2. That means the other 3 must add up to 19. You could have 6 pointing to 4 here. This has 4 digits that are part of its region. Oh, this 4 means this can't be 4. It's 6, which makes that 4. Interesting. So pink cannot go here. Pink has to go down here. Because it can't be part of the medium region because they both have 2s. And it can't be part of this cell because it has 4s. This is part of a separate region. So this is definitely pink here, and pink has to go down. Which means yellow has to go down because it has to still extend. We have 1, 2, 3, 4, 5, 6, potentially 7 cells. So it has to go down here, which means this is definite boundary. We have boundary there. This is interesting. So you could have 9 here, and then pink, yellow, and blue does satisfy that as a full region. So that is potentially possible. So this is boundary. Technically it could be part of green. So that could work. Be part of medium. That could work. How many cells do we have here? We have 27. So this could be 3 full regions here. Okay. Can this be pointing to 4? Yes, because 4 would be valid here. What about 5? So where could it point to 5 here? It cannot be pointing here. So 4 can... Okay, so if it's pointing at 4, it has to be 6 here. If it's pointing at 5, 5 can't be here. 5 obviously can't be the first digit then in that case. 5 can't be the 4th digit. It can't be the 8th. It would have to be the 9th. So if we had it pointing here, and that would be 5. That doesn't work because it's not going to be part of blue, and both of these are guaranteed to be blue. And it can't have 5 cells surrounding it. So this must be 6 pointing at 4. So this is boundary here. This is only 4 cells in the up to 9 cells surrounding it that are in the same region, so this cannot be the same region. So this is boundary there. And this must add up to, we have 2 and 6, that's 8. 21 minus 8 is 13. We don't have 4, 9 available. We don't have 6, 7 available, so it's 5 and 8. So this is 5, and that's 8. This is also a y. So we have the y done for, so the y and its sum done, the x, y, and sum done for 21. The x, y, and sum done for 9 here. The x, y, and sum done for this question mark. The x, y, and sum done for 27. The x, y, and sum done for 8. The x, y sum done for 18. The x, y sum done for 9 here. So we just have this one and this one left. Okay. This cannot be 6 or 8. There's no 8 here. Remaining digits in column 5 are 1, 3, 7, 9. Obviously no 3 here. Because of 3 in the row. Remaining digits here are 1, 3, 5, 8, and 9, because they're pink cells. This must be part of this region here. I don't really want to make it light. 8 eliminates 8 here, so this is 1, which makes this 8. That eliminates 8 in the rest of the row. 1 eliminates 1 here and 1 here, so this is 4 and 1 here. That means these can't be 1. Remaining digits in the medium region are 3, 4, 7, 9. Cannot be 4 because of 4 in the row. 6 eliminates 6 here. 8 eliminates 8 here. Okay. Okay. Blue needs access to a 2. It cannot get that 2 here, and it can only go out one more cell either here or here. So the 2, and this can't be 2 because of 2 in the column. So we're guaranteed a 2 here, which means this cannot be 2 here. Yellow also needs access to a 2. It's 1, 2, 3, 4, 5, 6, 7, and then it has to be 8 or 9 here, or 8 or 9 here, or 8 or 9 here. So it's guaranteed that there's going to be a 2 in one of these cells for the yellow. So we have a guaranteed 2 in rows 8 and 9, and another guaranteed 2 in rows 8 and 9, which means the 2 for this red. Actually, can this ever be... This can't be part of blue. It cannot be part of yellow. Technically, it could be part of pink. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6, 7, 8, 9. Does that work? So I don't think that works. Okay, so 1, 2, you could have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we tried that, we have how many yellows and how many blues? Okay, so yellows and blues. 1, 2, 3, we have... How many cells are yellows and blues? This is 9 and this is 7. So we only have 2 more yellows and blues possible. If red were part of the pink region, then there's no way that you can connect it without leaving a cell that doesn't have a region. So say this is 18 right now, yellows and blues. So say these were also yellow and blue. That means the rest has to be, if we try to connect as red to the pink region, 1, 2, 3, 4, 5, 6, 7, 8, 9, this cell is not going to be part of a region. So it cannot be part of the pink region. And if we try to not make it part of the green region, it has to have its own separate region, so that's 9 there. Pink is not going to be able to form a full region. Therefore, red has to be part of this green region here. So then we can make all of this red. That connects this way. That means all of these are red, and that's done as a region. And again, like I said, this has to be one that's 8. If we try to have 1, 2, 4, 5, this is not going to have 4 cells that are part of the same region. So this, we're going to make it green. This then can never be yellow, so that has to be pink. We can't have yellow go that way because that would block the pink from being full as a region. So this is pink here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 at most. So this must be pink. This, again, cannot be 1. No 8 here. If we try to have 1, 2, 4, 5, you would have to have 2 here, 4 here, and this doesn't have 4 cells in the same region as it has 6 cells. So that doesn't work. So this must be 1, 2, 3, 6. 2 and 3 cannot be pointing to stuff here in the same region, so this must be 6 outside. That means this is 2, 3 as a pair. This is 4, 5, 7. Oh, that doesn't work. We have a 6 and 6 pair. Ooh, that's really bad. Shoot. No! Everything was working so well. What the heck? Shoot. It was working so well. And now we're defeated by the 6, and that's it. No. 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 I think it has to still be that way then. Can't be part of yellow. It can't be its own separate region. It can't be pink anymore. Ugh, that's horrible. I'm pretty sure this is the path. That's the solution. But obviously it's having problems here. Because everything fits just so well together that this way. But the problem is this can't be 6 anymore because of that 6. Yeah, the only way you had 7 was if it was with 2. So that's why that couldn't work. Shoot. Hmm. Did I mess something up? Probably. Well, obviously. I had to mess something up. That sucks. Shoot. Everything was flowing so well too. Okay. I think we have to get back to the 9s then. I don't know if the 9s is valid. Okay. We do have to have one of them pointing at a 2. I guess this doesn't necessarily have to point to a 2. Yeah, maybe that's it. Maybe that's it. Hmm. I'm gonna pause. I need to go to the bathroom. I'll be right back. And I'm back. Okay, let's continue. That's disappointing. Okay. Right, so I did make the assumption that that this one had to be a 2. I don't think I made that assumption with this. Maybe I did. Actually, I did make the assumption that that was 2 also. One of them has to be a 2, but both of them don't have to be. That is the case. Okay. And I think we've just shown that it doesn't work for 2 to be the y for both of them. So we had it where this was pointing at a 2, and that necessarily eliminated these from being a 3. So what happens if we have this be the 2 and this be the 3? So this was pointing at 3. That would mean you have 5 digits adding up to 18. You could have 1, 2, 3, 4, 8. 2, 3, 4 with 1 and 8. That's kind of weird though, that it worked so well for the 2 cells here, and then we ran into a contradiction here. That's so weird that you would that would happen. I mean, that's telling me that that's probably the actual correct path. But right now, we're running into that contradiction. Okay. For 3 digits to add up to 9. Oh, yeah, this... Well, this one could be going something like... Oh. This cannot be the 3. If this were 3, that would mean... How does this break apart? This is part of either medium or blue. Well, so if yellow were something's completely separate, the problem... Okay, so the problem is we have to have one here. I guess that's possible. 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the potentially is possible that way. So this could actually be 3 also. Okay. Well, that's that ain't okay. Well, that's not helpful. So one of these has to be pointing at a 2. We don't know which. Okay. Yeah, so where can the 2 be? 2 cannot be here or here. Because if 2 were here or here, you would necessarily have that being 2 digits here connected, 2 digits here connected, and then it has to exit out. But it has to exit out being in the neighborhood of the 2's here. So 2 cannot be either of these. 2 can't be here for the same reason. And well, not for the same reason. If this is 2, these 3 digits cannot add up to 27 with the 2. So you would have to have one extension here, which would mean that this can't be 2 here. So we're guaranteed 2 has to be either here or here. Now this could... Okay. So if this were 2... I guess it could just go that... No. It has to go that way. Okay, so it can't be full 3 because, again, to connect this as a this has to have a full regions here. This would have to then go that way. It can't just go 2 that way and extend this way because then we have 2 regions here, which are blocked by this cell here because it can't reach... These cells can't be the same region as it. So if we have a 2 here, it has to go either 2 that way or 2 that way. It cannot go 2 that way because then we have 2. This can't go here, can't connect to here. So this has to go this way. And then this has 2 regions here, which must be filled by only 10 cells, which obviously doesn't work. So if this is 2, it can't go 2 here because that's too few cells. So if it goes like that, the problem is this is still a part of a region which doesn't have a full region. So if we try to go 2 this way, so if we try to go 2 here, how does that work? So it's obviously not part of yellow. It has to go out here. It's not part of pink. So pink has to go out here. Guaranteed. I mean, I guess this could be dark, but pink has to get out here. And this still doesn't work. I don't think. Well, maybe. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it does not work. How do these cells exit out? So we have both of these. So these are 2 separate regions. You can't have a full 9 here. So for this region, we try to have a full 9, and it would have to be here. But then this region doesn't exit out, and it can't be a full region. So therefore, that doesn't work. And if we try to have this as a full 9, that also doesn't work. So this cannot be the 2 here, ever. Which means that we know this is 2. And it cannot be part of this region, can't be part of this. So this does actually still work. We have boundary here, boundary here, boundary here. This is boundary. But this could be 3 now. We know it can't be 2 and 7, so that doesn't work. This can't be 2 and 7 either. If it's 3 digits... So, okay, what are the possibilities? If it's 2 digits... So if we try to have 1 and 8 here... So this is definitely a Y, period. So this must be going dark out here. Therefore, this is boundary here. If this is 8, it has to point to 2. So it can be 8, 1. But that's not possible. If it's 6, it must be pointing at 2, because it can't be 1, 2, 6 adding up to 9 anymore. So this cannot be 6 here. This could be pointing at 6, though. So one of these is going to have to be 3, 6, or 4, 5. The only way you get 3 digits adding up together is 1, 3, 5. Which necessarily removes the possibility of 3, 6, and 4, 5. Shoot, so I'm still running into the same problem, then. This must be 4 pointing at 2. This must be 6 pointing at the 2. And then this is 6, 3. And then... I feel like this is the solution. So then why is it failing? Well, it's failing because this can't be 6 and 6 there. But the thing is, this is the only place you can ever have 2, which are guaranteed to have the 2, right? Yeah, I feel like this is the solution path, but the problem is that we're running into a contradiction. I'm not feeling good here. Oh, this is making my skin, like, creep. Ugh. Do we have to go through this assumption? I feel like this was very solid here. Maybe. Obviously, this can't be 4 and 4, so that's a fail. Dang it. I think I might have to go from the beginning. I feel like this is the solution path, though. But I just... Even if this is... Well, no, that does help if this is 2, right? Then this becomes 7. Or, sorry, this becomes 3. And this could be... Well, 7 doesn't work. That actually doesn't work, period. Huh. Shoot. This is annoying. Okay. Y for a non-question mark can never be 1. Sorry, X can never be 1 for a non-question mark. It can't be 1 anyways, right? Y can never be 1 because Y would basically be then that it only has one cell in the region in the surrounding region that is in the same region, which is impossible because you have to have 2 cells. So Y can never be 1, which means X can never be 1 for any of the Y sum clues. And like I said, these have to be part of the same region. These are part of the same region. So that all works. Okay. So this is 3 cells at least. This is 2 cells here to add up to 12. We have, can never be 1 cell here. So this is 2 cells here, 2 cells here, 2 cells here, 4 cells here. 4 cells here because it can't be 3 because we have a 2 guaranteed here. 2 cells here and 2 cells here. Okay. For the... So that's actually very interesting. 2 cannot be the first X for that digit, right? Because it's saying that 2 is the sum, 2 is the Y, and then you can only get Y here. Actually, that could work. Maybe that's the assumption that we messed up on. You could have 2 here, and then it goes this way. This one particularly doesn't work because it blocks this. I still feel the other way is the correct way. So if we have 2 here, it can't be part of medium. It can't be part of... It could be part of orange. 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2... It has to go out this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 10 cells. So it cannot go this way. It cannot be 2 that way. What about 2 this way? Potentially. Cannot be part of blue. But it could be part of media. Unlikely. Actually, it can't. It could go this way, though. No, it's not going to work. So if we try to have 2 going this way, 2 and 7, and 2 and 7, that could technically work, but the problem is it would have to go something funky like this. And then the other set of 3 digits would have to be 1, 3, 5. Okay, so let's not go with this part yet. Let's try to do these. Okay, so what digits can be here? You can't have 2. 2, 7 would mean that it's saying Y is in the 2 spot. Yeah, actually, it's going to be problematic with 2 and 3 as the Ys. Well, okay. How do you have 2 and 3s as the Ys? Obviously, you can't have 2 3s, because then that's 6 digits trying to add up to 18. So you have to have one. If you have a 3 as a Y, it has to be 2 and 3 as sets. So you could have 1 8 with 2 3 4. 1 8 with 2 3. Oh, you could have a 2 3 4. Huh. That is, well, no, but the same problem, right? 1 8 2 3 4. 2, 7, 1, 3, 5. 3, 6 doesn't work. Or 1, 2, 6, 4, 5. Okay. Let's try 8, 1, 2, 3, 4. 1 cannot obviously be the x for either of them. So if we have 8, 1, that would force this to be 2, 3, and 4. This is part of the same region, so this does not have two cells that are part of that region. And if we try the other way around, it's the same way. So it cannot be 1, 8 with 2, 3, 4. What about 2, 7 with 1, 3, 5? The problem is the 2, 7 works, potentially, but the 1, 3, 5, they have to point to the 3. And 1 can't point to a 3 because it's pointing to itself. 3 would be pointing to a different digit in the third position, so that can't work. And 5 would be pointing to a 3 that's outside that position. So 1, 3, 5 and 2, 7 does not work. So that means we're left with 1, 2, 6 and 4, 5. But 4 and 5 are pointing. Yeah, so you're guaranteed that you cannot have. You're guaranteed that you cannot be pointing at a set of 3 and a set of 2. Because we tried all of them, right? We have 8 and 1 pointing at 2, 3, and 2, 3, 4. 8 has to be the x here, which means 2 is there, but 2 would be between the 3 and the 4, which must be part of the same region. So it would have 3 cells in the surrounding cells that are part of the same region. So that rules out 1, 8, 2, 3, 4. 2, 7 doesn't work because 1, 3, and 5 cannot point to the 3 itself in its own region. It just can't point to it. And then the last one's 1, 2, 6 with 4 and 5. The problem is the 4 and 5 have to point to the 2, which is on the other side, but 4 and 5 can't reach that. So therefore, that doesn't work. These have to then be 2 cells each, guaranteed. So this is 2 cells and 2 cells, guaranteed. We cannot have a 2 here. We actually could have a 2 in one of these spots. So the 2 has to be either in 3, 7 or 4, 6. But it can't be in the 7 spot. Because if it's in the 7 spot in 1, that would have to be 7 and 2, adding up to 9. So this has to be a 4-6 pair here, which makes this 3 and 5 to be corresponding. The remaining digits in the column then have to be 1, 2, 7, 8, 9. And 2 cannot be in the 3rd, 5th, or 7th spots, so 2 has to be one of these 2. Right? I think we've proven that. If this were 2 here, this is problematic. If we tried to have a 2 here, this is very problematic because the 8 would have to point to it because you can't have 1, 3, 4 adding up to 8. Why can't you have that? 1, 3, 4 adding up to 8. because it would need to be pointing at itself, and you have the same problem that you had with 1, 3, 5, right? 1 cannot be pointing at the 3 because it's pointing at itself. 3 cannot be pointing at the 3 because it's pointing to the third digit. 4 would be pointing to a digit that's outside of the first 3 digits, which 1, 3, and 4 would have to be. So 2 does not work here, period. So 2 has to be here. That means this must be 4 here, and this must be 6, so that's 3 and 5. So you're guaranteed that this is the case. This is why here it cannot be 2 going that way, because then it has to go that way. This is not part of this region or this region. So this has to go this way. Okay. So this is definitely boundaries. This is a boundary. Can this be part of... So these are separate boundaries. So these are different region than this. If this is part of this region, this would have to be a different region. And this is not part of orange. We cannot connect to orange. So this would be 9 cells at most, and that would block this. So this cannot be part of this region here. Can this be a separate region than this? If it's a separate region than this could be medium. This has to go 9 here, and then this is blocked as a region. So the answer is no. So this is boundary here, boundary here. Therefore, this must be part of this region. So that's guaranteed. It can't be part of this region and this region and this region. That's already 7 cells there. This has to connect here. So 7 cells here, then it doesn't connect because 8, 9 is there. So this cannot be part of the dark region. It's part of something else. It can't be part of this region here because that would cut this dark region into 2 separate regions. So it must be part of this one to exit out. Therefore, this goes this way. Cannot be part of that, so it has to go that way. This is, again, orange or dark. This is 5 cells. So, okay, so this cannot be region. This cannot be region. So this has to be part of medium. This is already too many cells, so this can't be part of that region. Can this be 3 digits? 1, 2, and 5. And that would force this to be 3. Then you... Okay, so that's the same problem here. If you have 1, 2, and 5. 1, 3, 4 cannot be pointing to itself anyways. So 1, 2, and 5 would be pointing... Cannot be pointing to 1 and 2 in its position, so it has to be pointing to 5. But then this would have to be 3 digits pointing to the 3, but without a 5, and that's not possible. So this has to be 2 cells. And cannot be 7, 1? Maybe this could be 2. I'm pretty sure that's not going to work, but let's try that. So say we had 7, 1. This is 2. Can you have 4 digits adding up to 18? I mean, yeah. 2, 3, 4, and 9. 2, 3, 5, and 8? Maybe this is the solution. That's funky. Oh, no, that doesn't work. Because 7's pointing at 2 here. This can only have 2 cells part of the region. Right, and that's the reasoning why. So then this has to be 3 cells as part of the region, which would be 2, 7, 9, which is not possible. So, again, that doesn't work. It cannot be 5 pointing at the 2 here. So it must be 3 pointing at the 2 there. So that's 3 and 5. It's just still the same. The remaining digits in row 6, we have 1, 4, 6, 7, 8, 9. You again cannot have 1, 4... To have 4 digits add up, it would be 1, 4, 6, and 7, but none of them are pointing to the 4 that's in the same... in that Y sum. 1 would be pointing to itself. 4 would be pointing to the 4th digit, which is not 4. 6 and 7 would be pointing outside of the sum. So it cannot be 1, 4, 6, 7 to add up to 18. It has to be 3 digits. So therefore, it must be pointing at the 3 there. So this is 9, which again gives us the same issue. Ugh. 2 digits adding up to 18 minus 9, which is 9. So cannot be 2, 7, no 3, 6, or no 4, 5 because of 2, 3, and 5 in the row. So this has to be 1, 8. And we still have the same freaking problem. So this can't be 1, 8, or 9. It has to be 7. This is so annoying. Well, I already knew that this was going to be the case anyway, so that's kind of par for the course. This has to have 2. It cannot go 2 down here because then it has to exit out. This can't be a full 9 because the problem is this only has 3 cells that are part of its region. So we know this is a boundary there. So it cannot go down, it has to go this way. So again, it cannot be part of orange for the same reason. Actually, it's also for too many cell digits in the same cell or in the same neighboring region. This is boundary here. Ugh. To add up to 12. So we have... So again, to add up... If this is part of the same region... 1, 2, 4, 5... It would have to be basically this is full as a region. So it'd have to be 1, 2, 4, 5. But the problem... Oh, well, 4 can't be pointing at itself. Right? 4 would be pointing to 1 if that were 4. So that's why this couldn't be... That 4 doesn't work there. So it has to be 1, 2, 3, 6, which means it must be pointing at a 4 outside, but this can't be... That would have to be 6 there, but it can't do that anymore. This sucks. This has to be pointing to a 5. This doesn't have 5 surrounding cells. 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 This doesn't have 5 surrounding cells because it would have to be dark if that were the case. And then you'd have 2 5s in the same region. So this has to be this doesn't have 5 surrounding cells in the same region, so this has to be 5. Points at 8. This does not have an 8. Again, one of these has to be 5 because 5 can't be here or here. This must be dark. This is dark or medium. This cannot be orange. We have 1, 2, 3, 4, 5, 6, 7, 8 cells in the orange region. So you could go orange here or orange here. That's it. Five has to be part of this. So if it's 5 cells adding up to 27, it has to point to the 5 here, which would have to be either here or here, which it does not have 5 cells in the same region. So this cannot be 5, it has to be 4. Yeah, we're running into the same thing. This is not dark, this is orange, this can't be medium, it's dark. I mean, it made sense, so that's why it was so frustrating. This has to be 9, 5, 6, 7. 5 is here. This is 6 or 7 then. Maybe it's the 6 or 7 here. Maybe. I don't know. Blue cannot go out this way. Blue has to go out this way. So this is blue here because this has to go out. So we're making that yellow. Yellow has to go out that way. This is blue or yellow. Yellow has to go out that way. Pink has to get... Well, we don't know. So how did we get a 6, 7? How did we get a 7 there? Maybe that's the problem. Oh, no, because this can't have a 6. Right. Remaining, this is 3. This has to be 1, 2, 4. Shoot. And this can't have a 6 because this 6 is basically causing all the problems. So because 6 can't be in the blue region, this can't be 6. It's 7, 9 as a pair, which forces this to be 6, that to be 7. The X is 6 now, which means that the 4 has to be in the Y position, or in the 6 position. Therefore, that's not 4. This is 6, that's 4. The remaining digits are 1, 2, 3, and 8. No 2 here because it's 2 in the column. This sucks. Pink cannot go here. Pink cannot go here because this has a 2 in the region. This has a 4. So pink has to go down. Yellow has to go down. I hate it because I really dislike it because the problem is that it just keeps going to the same path, and then leads me to the contradiction again. So if we have 9 here, it's not enough. It's just not enough. We have 16 here. So 10 plus 4. We need 2 more. And then this isn't large enough as a region for pink. 1, 2, 3, 4, 5, 6, 7. So that fails. And we have the same freaking problem over and over and over again. Ah! Yeah, because the problem isn't that. Yeah, the problem. So either this is a separate region than the green, or it's basically the same as green. The same as green works fine, except that the 6 here eliminates that possibility. You can't have 1, 2, 4, 5 because it would be pointing at itself, and then 4 as a digits would basically not be in the same region unless it's here, but then the problem is it can't point to there. So Ugh, this sucks. Yeah, it's this 6 that's causing all sorts of problems, essentially. But I'm pretty sure that has to be the 6. We tried the 2. We tried that this is one of these was 3 and then one of these was 2, and it just doesn't work. And then the problem is this 6 causes a lot of repercussions. It forces that to be 6, which means that's the x, which points to a 4 there, which blocks this area, so this can't go out there. This 6 also blocks this from being a full region. So it's just that 6 is causing all the friggin' problems. It's so annoying. The problem, and it really, what's so frustrating is I see the path, but the problem is I don't see a way that this path actually works. And that's when I get most frustrated because it's not it's there's it's just I don't know. It's like that you're missing something really stupid. And it's usually something that you're just overlooking. But the thing is, I don't feel like I'm overlooking it, right? And I feel like I know what I mean. I understand what the implications are. Ah, obviously you can't have 5 digits adding up to 12 or less, or 15 or less, essentially. Oh, it could be part of green. I see. It still could be part of green. That's where I made it. That's where I okay. There we go. That was the stupid. That was the stupid thing. I the stupid part of me that didn't see it. This does have to be part of green, but it doesn't have to be 4. It has to exit out some other way. And so, okay. That is where I messed up. Or basically just completely could not see it. It has to be 2 digits here. It cannot be 4 digits because, again, like I said, This 6 basically forces this not to be 6 here. So this has to go, okay, this is 4. So this is still the same. Okay, good. There we go. Okay. This is still the same. So how many digits can this be? It's either 4 or 5. 5 can't be here, 5 can't be here. This has to be pointing then to either 7 or 9. 7 can't be 5 because of 5 there. So this would have to be, if this is pointing to 5, it would have to have a 9 here, right? If it's pointing to 4, it has to be 6. So we have 6 or 9. If we have 9, that would then be 5 there. Oh. That can't work? It could technically work. I think there's a problem adding up. So if this is 9 and 2, pointing at a 5. Oh, it's because of the way that the coloring works, right? Yeah, that's it. So the cells that it's part of the region, it'd have to have 5 cells that are part of its region, which would mean it's blue, but they can't be part of the blue region. So that's why it can't be 9. So this has to be then 6 pointing at the 4 here. Okay, so then we have that. This is boundary here. These must be part of this region here. But, because it has to exit out. But, it cannot connect directly to that. And that's where we messed up. So this be 2 digits adding 8. We can't have 4 digits. We tried that multiple times. We have to have 2 digits here adding up to 12. It cannot be going this way because so therefore this is a boundary here and this is a boundary here. It has to either connect this way or this way, and if we try connecting this way, this is going to be too small of a region, so it must connect this way, which means this is red, red. We have 1, 2, 3, 4, 5, 6, 7, 8. This cannot be yellow. It cannot be a full other region because we only have 2, 3, 4, 5, 6, 7 cells possible. So, and it cannot be part of yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9 doesn't reach there. This has to be part of pink. So this is part of pink here. And that was a stupid thing I was making a mistake on. It's basically this is 2 digits then. So it cannot be 9, cannot be 8. It's 5 or 7 here. So 2 has to be in one of those positions. Interesting. This is not part of pink. It's not part of medium. To add, so this adds up to 21. So 2 and 6. 21 minus 2 and 6. So I was right. This was the path. It's just that I kept messing this part up. Because I was like, this is not working as 4. And it's like, it doesn't have to be 4. That was where I messed up. Okay. I think this was 5 and 8 here. It can't be 4 and 9 adding up to 13, which is what 21 minus 2 and 6 is. Can't be 6, 7, so it has to be 5 and 8. Therefore, this is 8 here, and this is 5. This can't be 8 anymore here, so this must be what? 1, 3, 7, and 9. And no 3 here, no 3 here, because they're both in yellow. We know this is boundary because this has 4 cells that are part of its region. Therefore, this must be part of that cell there. We have 1, 2, 3, 4, 5, 6, 7. The remaining digits, I think red cannot be part of any of these cells. Because if it were... How many cells would we have left here? We'd have 1, 2, 3, 4, 5. This requires only 2. These require, what? It's 16, 2. So 2 and 2, and therefore red has to be one of these two. So therefore, yes, it cannot go that way. Yeah, this adds up to exactly 27, which is what 3 regions adds up to. So that's fine. So one of these is red. Yellow cannot go both here because that would block the pink out. So yellow could go up to here. It can't go to there, though, because that would be too far. It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 at most. Blue can go up to here. Pink cannot go here, because that would block the red. So pink has to go, it could go here. Those are possibilities, which means this is guaranteed to be red. Because yellow can't reach it, blue can't reach it, pink can't go that way because it would block red. So therefore, this is not red here, it's pink. One of these is pink. Therefore, this cannot reach pink here because it already has 8 cells in it. So therefore, this must be pink. This cannot be pink. It's yellow, which means this can't be blue because the yellow has to orthogonally connect, which means this can't be yellow, so that's blue. So that's done. This is done as a region. This is done as a region. This cannot be 3. It's a 179 triplet, which eliminates 179 in the rest of the block, or the region, and the column. So this can't be 3. It's 1. Sorry, this can't be 1. It's 3. This 179 eliminates... Okay, 8 eliminates 8 here, so that's 1, which makes this 8. So that's satisfactory. Where is the 2 in the blue region? It has to be one of these two. So 2 cannot be here. Where is 2 in the yellow region then? It can't be here because one of these is 2, and it can't be here because of 2 there. So 2 has to be there, which means this cannot be 2 here. So where's the 2 in the blue region? It must be here. This is 1, 4, or 8. 5 eliminates 5 here, so that's 7, which makes this 5. That means the x is 5, which means y has to be at 2. So this is 2. So it only has 2 cells which are part of its region. It cannot go this way, so this can't be 2 or 3. No 2 or 3 here. 2 can't be here, 2 can't be here. Whereas 2 in the red region, it's there. So this is a y. It cannot go here because then it has to exit out this way, and therefore this would have more than 2 cells part of a region. Could go here. No, it can't. Well, yes, it could if it goes that way, and then this is part. So this is definitely a boundary. So I guess we'll make this light, right? So 2 could go here or 2 could go here. It's not part of the medium region. It has to be part of this green region. The green region cannot go around here and connect to there because then this would not be a full region. So this must be green. And since it must be green, it has to connect all the way here. So then that's done as a region. So then it's going that way, which means green has to go... Whoops. What happened there? Green has to go this way. And that's 4 as a region, which is fine. We have boundary here. Green has to go here. Okay, remaining digits of the yellow region are 4 and 6. Remaining digits of the red region, well, we don't have 6 here because of 6 in the row, so 6 has to be here. That leaves this as a 3-4 pair, which eliminates 3 and 4 in the rest of the row. So this can't be 4 here. It's 1, 8 as a pair, which eliminates 1, 8 in the rest of the row and region. So this can't be 1 or 8. It's 4, which makes this 6, which makes that 4. Okay. 7 eliminates 7 here. Remaining digits of the pink region. We have 1, 3, 5, 8, 9. 8 cannot be any of these digits here because of 8 in the row. 3 and 5 are guaranteed to be here in the pink region, so this can't be 3 or 5. We have a 1, 8 pair in column 3, which eliminates 1 and 8 in the rest of the column. So this can't be 1 or 8, it's 9. This can't be 9, it's 1. This can't be 1 or 9, it's 8. That eliminates 9 from the rest of the row or region. This can't be 1 because of the 1, 8 pair in the column. This can't be 5 because of 5 in the column. 1 eliminates 1 here. Okay. So all of these should be satisfied now. Oh, this has to be pointing at 4, which is 7 or 9, but this does not have 4 cells that are part of its region. So this must be pointing at this one to satisfy there. So that's pointed at, which means this is 9, that's 7, which makes this 9 and 7. 4 eliminates 4 here, so it's 3, which eliminates 3 here, so it's 5. There's no 5 here. It's 1 and 3 as a pair. Okay, let's double check. 21. 6 is x, which points to y of 4, which has 4 cells in its region in the surrounding regions. That's saying 4 of these are in the same region and add up to 21, which is 2, 8, 5, 6 adding up to 21, and this is a separate region. That works. 4 is pointing at 2. So this is size 2, so y of 2, there is 2 cells in the region, which it is, and this is a different region, so 4 and 5 add up to 9. 6 is pointing at 2, 6 and 3 add up to 9, so therefore that satisfies that, and the 2 still has 2 cells in its region. 8 is pointing at 5, 5 has to be here, and it has 5 cells in its region, and this adds up to some number. 6 is pointing at 4, so this is y is 4. It has 4 cells in its region. This is 4 cells long, which adds up to 27. 5, 9 is 14. 6, 7 is 13, which adds up to 27 there. 1 eliminates 1 here, so that's 4 and 1. So we have 27. 3 is pointing at the third cell, which is 2. This has 2 cells in its region, and therefore this is 2 cells adding up to 8, which 3 and 5 do. 9 is pointing at 4, which has 4 cells in its region, and it's 4 cells this way, which does work. We already did this. 5 is pointing at 2, which has 2 cells in its region, and 5 and 7 does add up to 12, and this is a separate region. So that's there. And 9 is pointing at 3, which has 3 cells in its region, and 3 cells this way adds up to 18, which 1, 8, and 9 do, and this is a separate region. So now it's basically trying to solve for what these are. Okay. Remaining digits in column 8. We have 1, 6, 8, 9. Remaining digits in column 7. We have 1, 3, 7, 8, 9. Okay, no 1 here because of 1 in the rows. No 1 here because of 1's in the rows. This can't be 8 because of 8 in the row. No 8 here because of 8 in the row. No 3 here because of 3 in the row. Okay, this can't be 8 because of 8 in the region. So we have 3, 7, 9 there. Okay. Remaining digits of column 3, we have 2, 4, 6, 7. So no 2, 4 here, no 2 here, no 2 here. Where is the 2? It has to be here, which is part of the light region because the medium and the green regions both have a 2. So this is light. This cannot be a separate region than light, because if we try to, then this would not be a full region at all. So this must be light connecting that way. We have 4, 6, and 7. This can't be 4. Can this be part of medium? I don't think so. If this were part of medium, the problem is green. To connect, it would have to go that way, and green would be too small. And it's 6 cells already. Medium can go 1, 2, 3 at most. So this is 1, 2, 3, 4, 5, 6, 7. Therefore, this must be light and light. And that's the full region for light. which means, okay, medium has 3 more cells. Green cannot get to here because that would block medium off. So this must be medium there. This can't be green because that would block medium off. So this must be medium here, and medium has to go those 3, which means green has to be those 3. And these are the regions then. Okay. I think that's all the 2s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3s. Okay, remaining digits in column 1. We have 1, 3, 5, 7, 8. No 1, 5 here, no 1 here, no 8 here, no 3, 8 here because of digits in the rows. No 5 here because of digits in the row. This can't be 6 because of the 6 in the region. Wait, this is too large. 1, 2, 3, 4, 5, 6, no, 7, 8, 9. Okay. 4 cannot be here because of 4 in the column. So where's 4 in the medium gray region? It has to be here. So this is 4, which eliminates 4 here. That should be giving us 8 4s, right? 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6. Yeah, 7. Wait, that's not right. We're missing a light. Oh, this is 5. Yes. So that gives us 8 4s. So we know where the last 4 has to be. It has to be there. Okay. We need a 9 in the light region, so it can only be here. We need a 6 in the light region, so it can only be there, which makes this 7. This can't be... the remaining digits in the medium region are 3, 7, 9, but this can't be 3 or 9 because of 3 or 9 in the row. So this is 7. That makes this 3 or 9. This 3 or 9. This can't be 7. 9 eliminates 9 here, so this is 1, which eliminates 1 in the region and column, so this can't be 1. That's 8, which makes this 1. 1 and 7 eliminate 1 and 7 here, so it's 5, so there's no 5 there. This... okay. Remaining digits in the green region cannot have a 3. So this can't be 3. Where's the 3 in column 2? Can't be here. It has to be here. So this is 3, which makes that 1. 3 can't be here either. So where's 3 in column 4? It must be here. So that's 3, which makes that 9. This can't be 8 or 9. No 9 here. This 3 eliminates 3 here, so it's 7 and 3. This 9 eliminates 9 here. 7 eliminates 7 here. 3 and 7 eliminate 3 and 7 here, so that's 1, which makes this 8, which makes that 3, which makes that 7. And 6 eliminates 6 here. This has to be 8, 9 remaining in row 4. This can't be 8 because of 8 in the column. So this is 9, which makes this 8, which makes that 6, which makes that 9. That leaves this as a 6 here. Remaining digit in column 4 is a 5. Remaining digit in row 3 is an 8, which eliminates 8 here. So it's 1, 8, and 1. And that was really annoying that I made that really dumb assumption. That's why I get so frustrated, because it's like I know this is the path. What am I completely missing? And it was a really dumb assumption there. And that's why I just get so frustrated, because it's just like I know I'm missing something stupid. And I was something stupid. It was just like, what am I missing that's obvious? And it's like, oh, it's that this doesn't have to go 4 that way. It's just like, oh. why did I like? Why am I being so stupid? There, essentially, is the thing, and that's why I was really frustrated because it was just like I know I'm missing something, and I know it's something, that I'm being dumb on, right? And it was. It was being really stupid there. Uh, it's just, sometimes it happens though. You gotta forgive yourself. Even though you're stupid, Frank, sometimes you're still a good person. So, and hopefully that's a good lesson for you guys. Acknowledge when you're being stupid and accept that and say, you know what, I gotta be better or not be better, but it's fine. Sometimes you'll be stupid. We're all human, and it just happens. But hopefully you enjoyed me banging my head against my stupidity. Um, and I guess I'll see you next time on Frank Puzzles. Take care.